All right, let's dive into one of the most, well, intuitive and yet surprisingly powerful algorithms in all of machine learning, K-nearest neighbors. It's so simple, so effective, and you probably use the same logic every single day without even realizing it. So let's get into it.
So to get our heads around how this all works, let's just start with a really simple scenario. Picture this. You've just packed up and moved into a new house in a town where you don't know a single soul.
So what do? What's your first move to get a feel for the place? Are the folks here friendly? What's the general vibe? How do you even start to figure out your new environment? Well, the answer is actually incredibly simple.
You look at the people closest to you, right? You check out who lives next door, who's across the street. You kind of watch their habits, see what their homes are like. You just instinctively assume that your immediate surroundings are going to tell you a whole lot about your new spot. And that very human instinct, that's the heart of this algorithm.
It really all just boils down to this old saying. The core idea, the big assumption, is that similar things exist near each other. In data, just like in life, if you want to understand something new, you just look at what's closest to it. And that leads us straight to the official definition. K-nearest neighbors, or KNN, is an algorithm that figures out what a new piece of data is all about by looking at its closest buddies. And that K? That's just the number of neighbors you decide to ask. Are you going to ask your 3 closest neighbors? Or maybe your 7 closest? That number, that K, is totally up to you.
Okay, so how does this whole surveying the neighborhood thing actually work under the hood? Let's break down the simple, step-by-step rulebook that KNN follows.
The process is incredibly straightforward. Just 4 steps. First, it literally just stores all the data. That's it. It just maps out the whole neighborhood, and that's why people call it a lazy learner. Then, step 2, when a new house pops up, it calculates its distance to every single other house. Third, it picks out the K-nearest neighbors you told it to find. And finally, it makes a prediction. It either has those neighbors vote on a category, or it just averages out their values. Simple as that.
But here's the thing. As simple as it sounds, you still have to make 2 really important decisions before you can get started. And these choices, they're going to totally define how your algorithm sees the neighborhood.
So, the first big question is all about that letter K. How many neighbors are you actually going to consult? Just 1? Maybe 5? Or 50? This one little number can totally change your results.
Yeah, choosing K is a real balancing act. If you pick a small K, like you see on the left, you get really good at spotting local patterns, but you can be easily thrown off by weird outliers, like asking only your one really eccentric neighbor for advice. But if you pick a large K, on the right, you get a much more stable, smooth prediction, but you might miss some of the important local details. Oh, and a little pro tip, data scientists almost always choose an odd number for K. Why? To make sure there are no ties in the final vote.
All right, the next big decision is just as critical. When we're talking about nearest or closest, what do we actually mean? How are we measuring that distance?
Well, there are a few common ways to do this. The most popular one is called Euclidean distance. That's just the straight line as the crow flies distance between 2 points. Easy. Then there's Manhattan distance, which is perfect if your data is like a city grid where you have to go block by block and can't just cut through buildings. And for data that isn't even about numbers, say you're comparing text, you might use something called Hamming distance. The one you pick really just depends on what your data looks like.
Okay, so the whole neighborhood analogy makes sense, right? Now let's see how this super simple idea gets applied to all sorts of complex, real-world problems.
So KNN is a great multitasker. It's got 2 main jobs. The first one is classification. This is when it takes that majority vote from the neighbors to decide on a label, like, is this email spam or not spam? The second job is regression. That's when it predicts an actual number by just taking the average value of its neighbors, like predicting the price of a house based on the prices of similar houses nearby.
And this is where it gets really powerful. Think about your favorite streaming service. It uses something like KNN to find other users, your neighbors, whose viewing habits are mathematically closest to yours. And then it just recommends the movies that your neighbors loved, but that you haven't seen yet. Pretty cool, huh?
Or get this, in medicine, KNN can actually help classify a patient's condition by finding past patient records with the most similar symptoms and vitals, their nearest neighbors. It can help doctors make a more informed diagnosis.
And in finance, it's used all the time for credit scoring. A bank can look at a new loan application and assess the risk by comparing that person's financial profile to a huge database of past borrowers, seeing how things turned out for their neighbors.
So, KNN sounds pretty amazing,
But, just like any neighborhood, it's not perfect. It's got some really wonderful strengths, but it also has some very real weaknesses that you have to know about. So on the plus side, its biggest win is just how simple it is. It's so easy to understand and explain. And because it's a lazy learner, there's no real training phase. It's just ready to go right away. It can adapt to new data instantly, and it handles problems with tons of different categories without any extra fuss.
However, and this is a big however, that laziness comes at a cost. Because it has to calculate the distance to every single point for each new prediction, it can be painfully slow if you have a huge dataset. It also has to keep all that data in memory, which can be a massive problem. And it also kind of falls apart in high dimensions. This is something called the curse of dimensionality. Basically, when you have too many features, everything starts to look equally far away from everything else, and the whole idea of a nearest neighbor starts to lose its meaning.
So here's the crucial point. If you take one thing away from this, let it be this. If you're going to use KNN, you absolutely positively must scale your data first. Imagine comparing houses based on number of bedrooms, maybe from 2 to 5, and also price, which could be from $200,000 to $5 million. If you don't scale it, the price is just going to completely dominate the distance math, and the number of bedrooms will basically be ignored. Scaling puts everything on a level playing field. It's essential.
So, at the end of the day, the story of KNN reveals a really powerful truth about the world of machine learning.
This algorithm is just a fantastic reminder that you don't always need some super complex black box model to get amazing results. Sometimes an effective solution that you can actually wrap your head around and explain to someone else is incredibly valuable. It's a foundational tool that really teaches us the core lessons about data, distance, and all the trade-offs we have to make.
And that kind of leaves us with a final question to chew on. As artificial intelligence gets more and more complicated and advanced, what can we still learn from its simplest, most intuitive ideas? Thanks for tuning in.